Welcome back, Focus Learners. Today's explainer is an absolutely crucial one because we are tackling a topic where so many students needlessly bleed points: data compression utilities across the Cambridge Computer Science and IT syllabuses. Whether you're taking 0417, 0478, 2210, 9618, or the 9626 syllabus we're focusing on today, the trap is exactly the same. You've spent hours studying the algorithms, right? You know your lossy from your lossless, but when exam day finally arrives, your marks just do not reflect your effort. I see this all the time. Imagine two typical students taking a past paper. Let's call them Alex and Sam. Alex is a walking textbook. Alex overloads every single answer with raw computer science facts, spilling out everything there is to know about run-length encoding or Huffman trees, but includes absolutely zero analysis of the specific scenario. The result? Barely any marks. Then there's Sam. Sam rushes the exam, completely ignores the command words in the prompt, and gives a generic answer that totally misses the requirements. Their papers come back covered in red ink. But today, we're flipping the script. I'm going to open up the examiner's playbook and show you exactly how to stop losing those easy marks. We're going to build a completely bulletproof, systematic strategy to dominate this specific question type.
Okay, let's dive into this. We've got a highly structured path today to decode exactly what the examiners are expecting from you. We'll start off with the core principles, then move into the procedural framework. After that, we'll look at how to elevate your answers with critical and comparative analysis. We will expose the biggest examiner warnings, the exact traps Alex and Sam fell into. And finally, we'll give you the ultimate exam blueprint to secure those top grades.
Section 1. Core Principles. Building the foundation.
Mastering data compression utilities requires a complete mental shift. I need you to really hear this. If you are relying purely on raw memorization, you are already behind. To stop losing marks, you need to understand the fundamental conceptual framework examiners are actually looking for when they mark your paper. They aren't just looking for you to regurgitate what a zip file is. They know you can memorize that. Success here requires systematic analysis and evidence-based reasoning. You need to look at a scenario, perhaps a company needing to transmit large, high-definition multimedia files over a severely bottlenecked network, and methodically reason out your solution using concrete evidence from the prompt. That's how we fix Alex's problem. We stop listing facts and start analyzing scenarios.
Why is this shift so important? Because examiners are targeting three very specific cognitive domains, also known as assessment objectives. First is your foundational knowledge and understanding of compression utilities. But honestly, that's just the baseline. The second domain is application. Can you apply that knowledge to a specific, unique scenario provided in the exam? And the third, the heaviest hitter, where the most marks live, is analysis. Can you break down the problem, interpret the variables, and logically deduce the best compression strategy? To hit these objectives, top students use something called the PEAL framework: point, evidence, explanation, link. You make your point about a compression utility, you provide evidence from the exam scenario, you explain how it works, and you link it back to the specific needs of the prompt. That is how you secure full marks. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Let's move on to Section 2, the procedural framework, systematic processing.
Knowing the theory is great, but how do we practically get it onto the exam paper efficiently? The source material reveals a highly standardized sequence for processing these questions. You absolutely must treat this like an algorithm. Here is the 5-step process to solve the rushing problem that our student Sam has. Step 1, identify the key elements from the text or data tables provided. Step 2, apply the relevant data compression principles. Step 3, execute your analysis, and we'll talk more about why clear working is your best friend in just a moment. Step 4, verify your results. Does your conclusion actually make sense for the given scenario? And finally, Step 5, present your findings in the appropriate format. This is where data interpretation becomes critical. You must extract the right evidence and draw solid, evidence-based conclusions.
So the crucial point here is that presentation is not optional. It is strictly graded. We've seen so many red pen marks transform into green check marks simply because the students structured their answer correctly. When you are writing out your answers regarding data compression, you must adhere to strict presentation conventions. Ask yourself, are you using proper headings? Are you using the correct syllabus-specific computer science terminology rather than vague everyday descriptions? Is your answer in the appropriate format requested by the prompt? And do you have clear annotations explaining your logic? Skipping these conventions is the absolute fastest way to leak marks, even if your underlying technical knowledge is totally solid.
Section 3, Critical and Comparative Analysis, Elevating Your Grade. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Let's start an interactive workshop right now to elevate your grade. We are moving into the territory of top-tier students. This is where we shift our focus to those higher-order cognitive domains. Challenge 1. Data scan. Imagine a complex computer science data table right in front of you. When an exam question uses the command word evaluate in a data compression scenario, they are asking you to rigorously assess the quality of the evidence. You have to identify the limitations of a proposed utility. You need to note any assumptions being made. For example, assuming a target audience actually has the processing power or software required to decompress a proprietary file type. You must find alternative interpretations and assess how these factors affect the final conclusion. It's about showing the examiner you see the whole chessboard, not just a single isolated move.
And this brilliantly illustrates the difference between an average answer and an outstanding one. Let's do challenge 2, find the flaw. Listen to this basic analysis paragraph. Utility A compresses by 50%. Utility B compresses by 80%. What's the flaw? The flaw is that it's just listing facts independently. That will not secure top marks. Comparative analysis, on the other hand, means identifying similarities and differences simultaneously, and crucially, using comparative connectives. Words like whereas, however, or in contrast. A perfect Peel paragraph would say, Utility B offers a higher compression ratio at 80%, whereas Utility A only offers 50%. However, Utility A is lossless, which is critical for the client's text-based financial data. You must support each comparison with evidence from the text and draw conclusions about their relative importance to the specific scenario. Moving on to Section 4, Examiner Warnings, the Pitfalls.
Which brings us to the climax of our explainer. We've dug directly into the principal examiner reports for Cambridge to find out exactly where students are failing. Here are the top 3 mistakes made on the data compression utilities topic. Mistake number 1. Answers are simply too vague. Examiners are desperate for specific technical details. Mistake number 2. Students completely forget to check their format and presentation, losing those procedural marks we talked about earlier. And mistake number 3, perhaps the most fatal of them all. Answers are not specific to the provided context. If you give a generic textbook answer about FLAC audio files to a scenario asking about compressing medical X-ray images, you will not get the marks. For Challenge 3, I want you to mentally do a speed writing exercise. Think about how you would write a perfect paragraph right now, avoiding these 3 exact traps. Now pay extremely close attention to this massive examiner alert regarding the method mark strategy. Students lose a tremendous amount of marks by not showing their working. Let me repeat that because it is vital. You must show your working. When analyzing compression ratios, storage capacities, or transmission speeds, even if your final calculated answer is completely wrong due to a silly math error under exam pressure, method marks can absolutely save your grade. The examiner actively wants to reward your process. Give them the opportunity to do so by writing down literally every single step of your logic on the page. Do not do the math in your head.
Section 5. The Exam Blueprint. Deconstruct, solve, evaluate.
Let's bring all of these principles together into your final computer science answering system. This is your actionable blueprint for your next paper, built on 3 golden rules: command word decoding, PIL framework application, and a strict time management matrix. When you turn the page and see a data compression question, do not panic and do not start writing immediately. Step 1. Deconstruct the question and extract every piece of given information. Decode that command word. Step 2. Break the problem into logical steps and select your analytical framework, like PIL. Step 3. Solve systematically, using clear notation to secure those method marks. Step 4. Step back and check for reasonableness. Think about it. Does a 99% lossless compression ratio on a complex encrypted file make sense here? Probably not. Step 5. Make your final justified recommendations using precise syllabus-correct terminology.
We've moved from raw memorization to a strategic, analytical approach that examiners are practically begging to see. You now have the procedural framework, the comparative analysis techniques, and the direct warnings from the examiners themselves. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.